about the differences between strong acids and weak acids. Let's start with just acids in general. In general, acids are substances that have lots of H pluses. This gives them a low pH, or pH that is less than 7.
What are we going to do for voices? Tomorrow.
However, acids break up into two categories, strong acids and weak acids. Both of these follow the rules for general acids, but there's a few more. For this example, let's use the general acid HA. HA will break up into H plus and A minus. For the strong acid, all of our HAs will be broken up, so we will just have H plus and A minus.
So as long as there's
This means that we're going to have 3 H pluses in the solution, which we're going to call a high concentration of H plus, which means it has a very low pH. For the weak acids, it doesn't break up entirely. So we're going to have some HA and some H plus. You'll see in the weak acids that we only have one H plus. And so one H plus, we're going to call that a low concentration of H plus. And it will have not quite as low of a pH. The reason that these break up differently is because of the Ka's of the acid. The Ka of a strong acid is much too large to measure, so we don't worry about it. But for a weak acid, the Ka determines how much it breaks up. So a high Ka means that there's a lot more H pluses and A minus than HA. And a low Ka means that there's a lot more HA and then there are H plus and A minus. So now let's look at what we do for titration of these two different types of acids. For a strong acid, it's going to start at a very low pH, and then once it reaches the equivalence point, it's going to go up very high, and then flatten off at the top. Here in the middle is the equivalence point. Which is at a pH of 7. Let's look a little bit closer about what is happening at the equivalence point. So that is when the OH minus and the H plus are equal, so they cancel out. And we're left with just our A minus and then whatever B plus was on our base. Neither of these will have any sort of acidity or basicity because both our acid and our base are strong. So we can cross that out too. And we're left with just plain H2O, which we know has a pH equal to 7. For the weak acids, we're going to start at a slightly higher pH. And as we go, it's going to angle up so it reaches the equivalence point, and then it'll flatten out just like a strong acid. At the equivalence point, our pH is going to be bigger than 7. Now let's look at why that is. Just the same as in the strong acid, the equivalence point is when the OH minus and the H plus are equal. So we cross them out. We still have this A minus and B plus. We still have a weak base, so the B plus still goes away. But we have a weak acid, which means that this A minus is slightly basic. So that means that we have a base and water, which will make our pH be above 7 in the basic range. Another important part of the weak acid titration is right here, which is the half equivalence point. This point is when the concentration of HA is equal to the concentration of A minus. This gives us a buffer solution, and it also means that the pKa or the negative log of the Ka, will be equal to the pH of the solution at that point. And then we can do some sample problems to figure out the pH of a weak and a strong acid. For a strong acid, we're going to take 0.1 molar HCl, which we know will completely break up into 0.1 molar H plus and 0.1 molar Cl minus. We need to worry about the concentration of H plus for our pH. You know that pH is equal to the negative log of the concentration of H plus. The negative log of 0.1 is just 1, so our pH will be equal to 1. This isn't very difficult. However, for the weak acids, it's a bit more complicated. For over here, we're going to start with 0.1 molar HS4 minus, which we know will partly break up into H plus and SO4. Our Ka for this is going to be 1.02 times 10 to the negative 7th. Now, to find out this pH, we're going to make an ice table. So we're just going to write out the generic equation. HA breaks up into H plus and A minus. Then we have our initial, change, and equilibrium. Make this chart. So we start with 0.1 molar HA, no H plus, and no A minus. So then we're going to subtract X, add X, and we're going to end up with 0.1 minus X, X, and X. So then, we're going to write out our K expression. So our Ka is going to be equal to the concentration of H plus and the concentration of A minus over the concentration of HA. So if we put that in, that's going to be 1.02 times 10 to the negative 7 is equal to x squared for the x times the x over 0.1 minus x. Since this is to a negative 7, we can assume that this x is going to be very small and get rid of it. So now what we need to do is multiply both sides by 0.1. And we will end up with 1.02 times 10 to the negative 8 equals x squared. So we'll take the square root of both sides, and that comes out to 1.01 times 10 to the negative 4, so we can just our x. Now that we found our x, we still need to get to pH, so we can see that this x is equal to the concentration of H plus. So we need to take the negative log of this. If you take the negative log of that, you're going to find out that your pH is equal to 4.